Hello, and welcome back to the Cracking Fang YouTube channel. Today we're going to be solving Leetcode problem 1011, capacity to ship packages within D days. At the moment, this question is really popular with Facebook, Amazon, and Google, so definitely one to know if you have an upcoming on-site interview with any of these companies. Let's read the problem statement. A conveyor belt has packages that must be shipped from one port to another within days. The ith package on the conveyor belt has a weight of weights of I. Each day, we load the ship with packages on the conveyor belt in the order given by weights. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within days. Cool, so that's the problem statement, but let's go through an example. For example, if we were given this array here, weights 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we were given 5 days to ship these packages, then our answer here would be 15. And let's kind of see how they derived that. Well, if we chose 15, we could ship these first packages on the day. So this would be what? This would be weights of 14 on that first day. This would be a weight of 13, then 8, 9, and 10. But that's not really intuitive. How the hell did they come up with 15, right? Like, it doesn't make any sense at all. So let's break this down and figure out a practical way to solve this problem that makes sense, because right now it seems like they just picked 15 out of a hat. So let's do that. All right, we've seen the example and we realized, hey, this doesn't make much sense. How did they get 15? Well, let's do this in an intuitive way. What is the minimum amount of weight that we could ship on a day? Well, if we think about this, the minimum weight we could choose has to be whatever the maximum weight of our packages here is. Why is that? Which in this case is going to be 10, right? Why is that? Well, if we chose anything less than the maximum weight of our array here, then we would never be able to ship that weight. For example, if we chose 9 as our maximum weight, we could ship every single package here, but we would never be able to ship this 10. Therefore, this would take an infinity amount of time and it would never work. So we know that the minimum weight we can choose from has to be the maximum of our array. Otherwise, we can't ship it. Cool, so that's the minimum weight we can choose, but what's the maximum weight we can choose? Well, if we think about it, the maximum weight is going to be whatever the sum of our weights is, right? Because in that case, we could ship everything on a single day. So, if we sum up this array, we're gonna get that the weight here is actually 55. So, we could choose 56, 57, 100, 100,000, 10 million, 100 billion for our weight. It wouldn't matter. We could still ship everything here. But remember that we're trying to find the least weight capacity that would allow us to ship these packages, right? If we chose 100 billion, we could ship this in 1 day still, but all we need is 55. So we're wasting weight capacity. So there's no reason to go any higher than whatever the sum of our weights here is. So that gives us the bounds of our, weight search, right? It's somewhere between 10 and 55. So if we kind of draw this out, we have 10, 11, 12, and then, some values here, and then we have like 54 and 55, right? And it's going to be all the values between, 10 and 55. And here I'm just I don't want to draw everything out. So what we could do is, we could start at 10 and we could say, okay, how many days would it take to ship these packages if we only use 10? And remember, we have to ship them in the order they come. So on the first day, we could ship 1, 2, 3, so that would be 6. So we could ship these packages, and that would take 1 day. Then on the next day, we have to ship this package 5, but we can't ship 5 and 6 because that would be 11. So we have to ship 5 on the next day, so that would take 2 days. On the next day, we'd have to ship the 6, so we'd ship that. It would take an extra day. Then we ship the 7, that takes an extra day. So now we're at 4. 8 would take its own day. So now we're at 5. And then 9 would take its own day. And then 10 would take 1 day. So we'd be at 7. So it would take 7 total days if we chose 10. And remember, we have 5, so this weight doesn't work. Okay, well, what if we tried 11? It's the same thing. I think it would take like 6 days in this case. But the point is, we can't ship it with this. Obviously, we know that the answer here is 15, so I'm going to kind of just do a little bit of skipping here. We would try 12, and we can't do it. So as you can see, we're going from left to right here, and we're basically just trying all of the weights. So that's, the first way to solve this is going to be, the linear solution, where basically we're going to start at the minimum weight we can do, which is going to be the maximum of the array. And we're going to walk towards whatever the sum of the array is, which is like the maximum possible weight we could choose for that day. And we're going to find the first value that trips this, that we can ship with. And we know that that's going to be our answer. So, doing this would take O of n time in the worst case times whatever the function cost is to figure out whether or not we can ship it. So, we'll kind of just assume that function takes O of n time to like sum up whether or not we can do it, right? Because we have to check all the days, so we'll just be going from left to right of the actual weights here. So this would be an O of n squared solution. Okay, but like I said, this is the first solution, and it's the linear solution. How can we do better than that? Well, one thing to realize is that we can't get away from this function here that does the summing to figure out, whether or not we can ship something on a day. This part we can't do better on, but do we actually have to scan from left to right to find this first point? And, the more keen of you will have realized, okay, well, we actually can do this in log time, because if you notice, we're going from 10 to 55, and this is increasing by 1 every time, which means that this array is actually sorted. So we're looking for the first value that trips, that would work for us, and we have a sorted array. So this should be screaming to you, hey, we need to use binary search here, so we can actually take our runtime complexity from O of n squared down to n log n times O of n. So we can reduce, this isn't n log n, this should just be log n. So our final solution is going to be n log n. So that's going to be the best thing that we can do if we use a binary search here. And this is really what your interviewer is looking for, how you're going to set up this binary search. And also, how you do this, the check whether or not you can ship it. So that's the two parts we need, right? We need the binary search part, and then we also need the some function to tell us whether or not we can ship our weights here. So now that we know that that's what we're looking for, let's go to the editor and actually write the code. And it's quite simple. All right, I'll see you there. Welcome back. Now we're in the editor. Let's write the code. So we know that we're going to do a binary search. So to do a binary search, you need a left and a right endpoint for your search. So let's define those. Remember that the left, which is going to represent the minimum weight that we can ship on a day, is going to be the maximum of the weights that we're given, right? So we're going to say max of weights. And the right endpoint is going to be the sum of the weights we're given. And if you don't understand how we got those, go back to the explanation portion where I go over why we choose the max as the minimum weight and the sum as the right endpoint. Cool. So let's set up our binary search. And remember that we're looking for the least value. So we won't actually be returning within our binary search. So we need to be careful to set up the binary search correctly. So in these cases where you're not actually returning a value from within the binary search, usually you use while left is less than right. If we're looking for something inside of the array, we would use left less than or equal to right. But in this case, since we're moving our pointer down, we're actually going to move the point. We're going to return the pointer value. We don't want to use the less than or equal to. So with a standard binary search, we're going to do mid equals to left plus right. Divide by 2, and there is a way to avoid overflow in Java. I'm using Python here, so look it up how to avoid the overflow in Java if you're using that, or C++. Anyway, so what are the two things that can happen here in our search, right? Either we can ship the weight or we can't. So we're going to define a function to do that in a second, but let's kind of just go through it conceptually. So we're going to say if self.canShip. So if we can ship the weight with whatever our mid, because that's going to represent the weight we're using, we're going to pass weights, and we're going to ship the days that we're allowed. If we can ship it with this weight, we need to move our endpoint, right? So we're going to say right equals mid. And why do we use mid instead of mid minus 1? Well, let's think about this. If we did mid minus 1, and it turns out that this weight mid was actually the answer, then if we did mid minus 1, then we would never return that value because we would accidentally go over it. So we can never do mid minus 1 when we know that we can ship it, because that could actually be that leftmost point and therefore our answer. So if we can ship with a weight, we have to use right equals mid. Conversely, if we can't ship the weight, then we know for sure that that value and anything to the left of it will never work, right? If a certain weight is not shippable, then any weight smaller than it will never be shippable. We can only look for larger weights. So when it's not shippable, then we can do mid plus 1. So in the end, all we have to do is actually return that right, because this is gonna be the solution. And this is usually the case when you're looking for kind of the leftmost or the rightmost value with the binary search. If you're just returning a value, you can typically do mid plus 1 and then mid minus 1 for whatever your left and right is, and you would use the less than or equal to up here. But in this case, where we're trying to find the leftmost or the smallest weight that we can use, we need to set it up this way. And if this is a little bit unclear, we're going to go back to the drawing board in the end, and I'll show you why this is the case so you can see it visually, because it is a little bit hard to conceptualize the binary search this way. So it is a little bit easier to just see it in actual, a diagram. Anyway, this is how the function to ship within days is going to need to look like, but we need to define our can ship. So let's do that. So we're going to say def can ship. And we're going to say self, and then this is going to be the candidate weight. It's going to take the weights and the days that we're allowed to use. So what we need to do is we need to track the current weight capacity of our ship, and we need to track the days that we've taken so far. So the current weight is going to equal 0 because we haven't loaded anything onto our ship. And we're going to say that days taken is going to equal to 1. And the reason that we're going to use 1, I'll explain at the end, but basically what we want to do is that we know that if we have the case where we're actually using the maximum amount of weight, then it's always going to take 1. If we did 0 within our code here, which you'll see in a second, we would never actually increment the days, and we would return 0, which isn't correct because we have to ship it in at least 1 day, right? We can't you can't ship in 0 days. So let's go through it. So we're going to say for the weight in weights, what's going to happen? We're going to say that the current weight of our ship, we're going to add the weight to it. Now, if the current weight of our ship exceeds the weight that we're allowed to use, which is the candidate weight, we know that our ship is overloaded and we weren't actually allowed to take that last weight. So what we need to do is we need to say, okay, well, we can send the ship off without this last weight here. So we're going to send it off, and we're going to say that days taken, we're going to add 1 to it. And then we need to reset our weight back to whatever the weight we just took was that caused us to trip. So for example, if the weight of our ship was 9 and the next weight was say 4, and we were only allowed to load 10 on a given day, obviously if we took the 4, then we'd be at a weight of 13. We can't do that. So we have to ship that 9 weight, and then the 4 is going to remain for the next day. So we do this for all the weights, and we're going to increment, our days taken as we go along. And this is the reason that actually, we need to start with days taken as 1, because if the candidate is actually the maximum weight, this cur weight will actually never be greater than the candidate, because they'll just be equal in the end, and we would never have incremented days taken, and therefore we would return 0. So that's why we need to return we need to start with days taken as 1. And in the end, all we need to do is return days taken is less than or equal to days, right? Because that's what we're looking for. We need to be able to ship the weight within days. So either we ship it within 5 days here, or less than that, for this particular example. So that's how you define the can ship function. Let's submit this and double check that it works. And once this runs, cool, we can see that it does, and it's quite quick because it's the binary search solution. So before we go back to the drawing board to actually talk about kind of how the binary search is set up in this case, let us talk about the time and space complexity. So what's going on here? Well, we know that we have a binary search. So any binary search is always going to be log of n, right? Now, that's going to be the binary search part, but within each binary search, we need to call this can_ship function. So let's find out what the time complexity of this can_ship function is. Well, in this case, what we do in the can_ship is basically we go from left to right to sum up, the current weight that we have and then compare it to our candidate. So really what we're doing is we're just doing a sum over the weights here. And in the worst case, we would have the maximum weight, which is going to be, remember, the total sum of the weight. So we would basically just sum our entire array. So in the worst case, this is going to be an O of n operation. So our time complexity in the end is going to be big O of n log n. Space complexity wise, at no point do we actually define any extra space for our solution here. We have this left and right pointer, but these are just pointers. These are constant space variables. So we don't actually define any new variables here. Same with these. These are just, pointer variables, like what's the current weight, what's the days taken. So we don't, define any arrays or anything like that. So the space complexity is actually going to be constant space, right? So that's the time and space complexity. Cool. At this point, let's go back to the drawing board and walk through a simple example so you can see why the binary search is set up in the way that it is, because it's a little bit hard to grasp if you've not really seen this before and you don't understand how binary searches that follow this pattern work. So I'll see you back at the editor in a second. Let's go over why the binary search actually is set up in the way that it is. If you already understand it and it's pretty intuitive to you, you can skip this part. Go watch another video if you want. You don't need it. If you were a little bit unclear, this is the portion of the video for you. So let's go into it. So we remember, what we do is we set up our left to be, this point here, which is the maximum of our array here. So this is going to be 4. And remember that the right point is going to be the actual sum of this array. So, if we sum this up, we actually get 16. And I've drawn this out. So basically we have all the values between 4 and 16 that could be the weight that we use. So remember, we're going to do while left is less than right. So, we pick a midpoint. What's the midpoint here? So it's going to be 4 plus 16. So 4 plus 16 equals 20 divided by 2 is going to be 10, right? So the midpoint is going to be 10 here. So we're going to choose 10 as our weight. Cool. So, can we ship with 10? Okay, let's check it out. So we could ship the 3 plus the 2, so that's going to be a weight of 5, plus the 2 again, so that's going to be 7, and then we get to the 4, so we can't ship that because it would go up to 11 here. So this weights would take 1 day. Then the next one would take, okay, well, we could ship the 4 plus 1, so that's going to be 5, plus 4, so that's going to be 9, so we can actually ship everything else on the second day. So it would take 2 days. So 10 works, right? So 10 works, which means that, 10 could be a potential solution. We don't need to check anything else here because these are all values greater than 10. And remember, we're looking for the least weight capacity. So we know if 10 works, we don't care about anything to the right of it because we know that at this point, it's fine. 10 could be our potential solution. We don't need to try anything larger than 10 because we're looking, again, for the least weight capacity. Cool. So now our right, if we remember back from the code, is going to equal to whatever the midpoint value was. So now our right is going to be 10. So let's keep going. Is 4 still less than 10? Yes, it is. So that means we have to calculate a new pinpoint. So we're going to say 4 plus 10 divided by 2. So this is going to be what? 7, right? So now we're at the 7. So let's try 7. Okay. Well, if we have our array here, let's see, we have 3. So on the first day, we could ship the 3. We could ship the 2. So that would be 6. And then 5. And then this one, that would be 7. So this would be, we could still ship it on 1 day. And then, so that would take 1 day. In this case, it would be 4 plus 1, 5. But we can't ship this last 4 because that would be 9. So that means that would take 2. And then this last 4 would take 3 days. So 7 works because it's, at least, within D days. So we're allowed, less than or equal to here. So 7 works. So that means that anything to the right of 7 is no longer valid as well. So we found a new best answer. So now our right is going to become 7. So what we want to do now is, okay, we need to calculate a new midpoint. So we're going to say 4 plus 7 divide by 2. So this is 11. Remember, we're using integer division. So this would really be, so this would be 11 divided by 2 is what? 5.5. And then since it's integer, it goes down to 5. So we're going to choose 5 here. So let us, and then I'll redraw this thing. So we have 3, 2, 2, 4, 1, 4. Okay, so can we ship it with 5? Okay, well, we could ship this in 1 day because that's 5. This is going to be 6 here, so we can't do it. So we have to ship the 2 separately. So we'd ship it. It takes its own day. We could ship this because it's 5, so that would take another day. And then this would take its own day. So this would take 4 days. So obviously 4 is greater than our allowed allotment of 3, so we can't actually ship it there. So that wouldn't work. So that means that 5 is not a viable solution. So that means our left pointer has to move up, right? So we said is mid plus 1. So it's going to be 6 here. So now our left is 6. Cool. So now let's go through the process again. And let's find a new midpoint. So we're going to say 6 plus 7 divided by 2. So this is 13 divided by 2. So that's going to be what? 6, right? Because it's, 6.5. And then obviously it's integer division. So we're truncating down to 6. Cool. So let's try now 6. So we're going to try, okay, can we ship this packages? Yes, this is going to be 5. So this is going to take 1 day. Obviously using the 2 wouldn't work because that would take us to 7. So then we reset it. So then on the second day, we could ship this because this is 6. And then on the last day, we could ship these 2 because this is going to be 5. So this would take 3 days. Cool. So we know that 6 works because we are within our 3 days, right? We take the 3 days. That's fine. So now we are good here. So now our right pointer becomes 6 because we set it equal to mid. So at this point, we have left equals 6 and right equals 6. And remember that our binary search is going to be while left is less than right. So in this case, they're actually equal. So this binary search would break. And remember, the last thing we need to do is actually just return the right, which is going to be 6. So that's how they derived it. Hopefully that's a little bit clearer explanation of how, the binary search works in this case, using, left minus right, and then moving, right equals mid if it's good, and then left equals, I guess, mid plus 1 if it doesn't work. If that was still unclear, go back over this explanation and hopefully, rewatch it as many times as you need to kind of visualize it, maybe even work through the example yourself, and it should start to click. So that's how you do Leetcode problem 1011, or I guess 1011, capacity to ship packages within D days. Hopefully you've enjoyed this video. This is actually a very common problem that you're going to see on Leetcode, not only because it uses binary search, which comes up in pretty much any company's on-site interviews these days, but I think the problems that are very similar to this are going to be cutting ribbons and Coco eating bananas. So if you want to take the knowledge that you learned from this problem, go try those out. If you don't understand it, I should have a video coming out real soon about those two problems. So if you don't understand how to do those problems, you can watch my videos and then hopefully you'll know how to do them. So thank you for watching. If you enjoyed this video, please like, comment, and subscribe, and make sure to watch all of my other videos if you're prepping for an on-site interview. Have a good one.